Hello dear students, I'm Meghamala, working assistant professor from Electronics and Communication Department, Institute of Aeronautical Engineering. And today I'm going to talk about the problem solving on data flow modeling. So quickly we'll move forward. So far we have discussed about all the modules in the Verilog as HDL. So coming to the today's topic, it's all about the problem solving on data flow modeling. So we know that what is a data flow modeling? Data flow modeling is nothing but the output are observed, or else the process will be done as per the data that we know about the regarding gates. Okay, so coming to the data flow modeling, it provides a means of describing the combinational circuits by their functions rather than by their gate structures. So here, from this point, from the very first point, we are telling that the data flow modeling, it describes about the combinational circuits. We discuss about the structure. Okay, we discuss about the structure, and that structure is formed with respect to the gates, right? So it provides the means of describing the combinational circuit by their functions rather than by their gate structures. So keenly we are discussing about the functioning of a particular block. Okay, that block which are constructed with the help of the gates. So we are purely discussing about the particular construction, or else we are describing about that particular block. Okay, and then this data flow modeling, it uses a number of operators that act as an operand to produce the desired result. So here the second point is all about this data flow modeling. It uses a number of operators. So we all know in the Verilog we have few lexical tokens. Those lexical tokens are in terms of keywords, in terms of operators, right? In terms of operators consist of the operands based on the operator. Okay, few operators they operate with the help of only two operands, and few more operators they operate, or else they give the expression with the help of only one operand, single operand operators. And a few more we can consider about the three operands, right? So keywords, operators, modules, right? And few more. These are nothing but the lexical tokens. So in the Verilog we have 7 lexical tokens, and each of the lexical tokens have their own specifications. So we know that already we have discussed about the operators. We have different types of operators in the Verilog. Few comes under like bitwise operators, few comes under logical operators, few comes under replace operators, and few comes under the bitwise operators, right? So here the data flow modeling, it uses a number of operators. So here the data flow modeling, it uses a number of operators that acts on the operands. Obviously the operators, each operators will they take considerations of the operands. As I said you, few operators they consider only single operands, right? Few more considers only two operands, A and B, and few other operators they consider 3 operands, A, B and C, right? So the data flow modeling uses the number of operators that acts on operands, obviously, to produce the desired result. So in order to produce the desired result, we are saying that the operators plays a major role in the data flow modeling, because we are concentrating on the describing of a particular circuit. Okay, rather than the gate structures, we are more concentrated on describing a particular logic diagram, or else a particular logic circuit, right? Then the data flow modeling, it uses continuous assignments and the keyword assign. Okay, continuous assignment and the keyword assign. A continuous assignment is a statement that assigns a value to a net. So in the data flow modeling, also we have discussed about different types of statements, right? Continuous assignment statement, implication statement, right? And then one more statement we have discussed, that is about the assignment statement. So assignment statements are nothing but the assignment statement consists of the operator. Operator is nothing but the equals to. Equals to is the assignment operator. In the assignment, every assignment consists of an operator equals to, and on to the left of the operator we have the LHS, and on to the right of the operator we have the RHS. So obviously onto the left of the assignment operator, which is represented with the equals to, this left hand side consists of the variables. Okay, the variables are, they could be in terms of net, or else they could be in terms of via, they could be in terms of other particular variations. But remember that onto the left of the operator we have the variables. We are designating the variables as in terms of net, and on to the right of the operator, assignment operator, obviously we have the expression to be followed, right? So here the data flow modeling, it uses continuous assignment statement. What does this continuous assignment statement mean? Continuous assignment statement is nothing but it is a statement where the execution takes place synchronously. Okay, continuously in a sequence manner, the execution of the program takes place, right? So this assignment statement consists of the few variables, and also they consist of the expressions. Then a continuous assignment is a statement that assigns a value to a net. So onto the net is nothing but a variable. So this variable will consist of some values. For example, I say onto the LHS, A is equals to 1 and B is equals to 2, right? A is equals to 1 and B is equals to 2. These are with respect to the via. Via A is equals to 1 and B is equals to 2, which is equals to the expression. So this is how the representing or else assigning some values onto variables in terms of the net. Okay, and then the data type net is used in Verilog HTL to represent a physical connection between the circuit elements. So here the data type net. So here the data type net is nothing but it is a via. So we can say that the data type net, data type is one of the few data types we have in the Verilog Verilog library, and those data types are named in terms of via, right? So what is a via? Via is nothing but it is meant to connect the two devices, the two micro devices we can able to connect these two micro devices with the help of a via called with the help of a data type called via. Wire is nothing but a physical connection which has to be made between the two elements, right? So here the data type net is used in Verilog HTL to represent a physical connection. Remember the physical connection. For example, I want to connect the element 1 and element 2. And this element 1 and element 2, I'm gonna connect it with a physical connection should be there. And for that purpose, I'm using a wire. So this is nothing but a wire, isn't it? So this is a wire. Wire is meant to connect the two elements which are present in that particular block diagram. Okay. So here the physical connection between the circuit elements, and then also in the data flow modeling, we are making use of operators. We are making use of data types, and also we are making use of the different statements, different assignment statement. For example, here most probably we are going with the continuous assignment statement, right? Then the value assigned to the net is specified by an expression that uses operands and operators. So we are discussing about this third point. So this point is closely related to the third point, where it says that the value which is assigned to a particular net. As I said net is nothing but a variable, a data type, where it consists of some variables or some values, right? So here the value which is assigned to a particular net. As I said A is equals to 1 and B is equals to 2. Right? So these are the values which I am giving to this particular data type net. A is equals to 1 and B is equals to 2. So what am I doing here? I am just assigning some values to a specified specifications to some questions. A is equals to 1 and B as 2. Right? By an expression that uses operands and operators. So here I can say that this is onto my left hand side of the assignment operator, and onto my right hand side I can say that Y is equals to A and B. That means what? My output will be 1 into 2. So it is 2, right? So this is what we can observe in the syntax when you are writing a program in terms of data flow modeling. So remember that data flow modeling, we can write the program, or else we can code a particular program in terms of by using the operators. Operators consist of the operands, and also by using the data data types, different data types. Data types are nothing but where the values are assigned to particular coefficients, right? Some values are to be assigned to some variables, and that variables are, it could be a physical connection variable like wire, and also they could be in terms of other variables which are not associated with the physical connections. Okay, I can say that wire is one of the data type, I can say net is one of the variable, I can say, right? So these are the things that we can observe in this data flow modeling. Then as an example, assuming that the variables were declared A to variables are declared. So here what am I doing is, as we are discussing about the problem solving in data flow modeling, so first basic problem that we are considering here is 2x1 multiplexer. Okay, so in 2x1 multiplexer coding, we will see how the operators or else how the operands are associated with the different operators, and how the data types are associated with particular assignment statements. Okay, so these are all we can observe in the particular example 2x1 multiplexer. So before going, so here we know that what is a multiplexer. Multiplexer is nothing but many to one, right? So many inputs we can give, but single output is observed. So here in the multiplexer we have different types of multiplexers in the digital circuits. We know that the different types of multiplexers are 2x1 mux, 4x1 mux, 8x1 mux, 16x1, right? So here in all these examples, if you observe, see, in all this example if you observe, the output is observed only a 1, right? Though we give the different, though we give the many inputs, but the output, only single output is observed. That is nothing but the multiplexer. And the opposite of this multiplexer is nothing but the demultiplexer. That is, a single output is given where it decodes into different different outputs, right? So it is 1 to many is nothing but the demultiplexer, and many to 1 is nothing but the multiplexer. So in the data flow modeling, we can write the code with respect to the multiplexer, and as well as with respect to the demultiplexers. And now we will see in detail how the variables and how the data types and how the operators can be associated with respect to this 2x1 multiplexer, right? So this 2x1 multiplexer consists of the data inputs A and B, and the selection input S, C, and the output as Y. So we know that see, for example 4x1 mux, for this 4x1 mux, how many inputs we have? We have 4 inputs, right? A, B, C, D has 4 inputs and 2 selection lines we have. Based on this selection lines, the output is going to be observed. So we move forward. So now this is nothing but as I said, when you're writing a particular code, so in data flow modeling, when you're writing the code, always remember that there are certain keywords that we need to mention. So for example, in the behavioral modeling, so we have 4 different types of modeling styles, right? First one is behavioral modeling, and the second one is behavioral modeling. Second one is data flow modeling. Third one is gate level modeling, and fourth one is switch level modeling, right? Switch level or circuit level modeling. So out of these 4 modeling styles, we will observe these 4 modeling styles in the Verilog HDL. So out of these 4 modeling styles, if you are considered to take any particular modeling style, so each and every modeling style will they have some specifications. That means in terms of coding, we need to specify some keywords. For example, if you are considering, or else if you are very deterministic to write your code in terms of behavioral modeling, remember that in the behavioral modeling, when you're writing a code, always at the rate, right? Always at the rate is the basic keywords where you need to mention, right? And then when it comes to data flow and gate level modeling, or its data flow, gate level and switch level modeling, what do we do is we use a keyword called assign. Assign is a keyword. So there are some basic keywords which are meant with respect to all these 4 behavioral, or else all these 4 modeling styles. So in the data flow modeling and also in the gate level modeling, what we do is as per this gate level and data flow modeling, we are gonna consider a basic keyword called assign, right? Assign is a basic keyword where we need to introduce when you're writing a code. So here in the data flow modeling, assign Y is equals to A and B, or A and S, B and S. Okay, so this is a basic keyword where you have to mention if you are writing your code in terms of data flow modeling. Then the data flow descriptions of 2x4 line decoder is shown in the HTML below. So as I said you, in the data flow modeling, we can write any sort of code, any sort of digital circuit you can consider. You can consider the digital circuits in terms of multiplexer. You can consider in terms of demultiplexer. You can consider decoder and the encoder as well. Okay, but the important thing you have to remember is when you are coding, when you are writing a code, particular code, mentioning of the keyword is very important. Okay, as you're writing your code in terms of data flow modeling, remember that SN is a keyword where you have to mention. So now, in the coming examples, we will be discussing about the 2 to 4 line decoder. So the circuit is defined with 4 continuous assignment statement using Boolean expressions, one of each output. So here, as we are discussing about the decoder, so what is a decoder? N input, 2 power n output, right? Isn't it? So this is a decoder, and opposite to the decoder is 2 power n input into n. That is nothing but the encoder, right? So here we are saying that as we are considering the example as 2 to 4 decoder, we see the data flow descriptions of 2 to 4 decoder with enable input as E, module decoder DF ABED. So here we know that when you are writing a particular code, remember that you have to start your code with a keyword called module. Right? When you're starting your keyword with a keyword called module, then obviously at the end of your code, you have to end it up with n module. Right? You have to end it up with n modules. So these are the basic things. These are the basic things where you have to follow, or else you need to remember if you're writing a particular code. Obviously, we have in the, as we know that we have 7 lexical tokens in the Verilog. So out of these 7 lexical tokens, we have discussed each and every in detail, right? So this module and n module, they comes under the keyword, under the lexical token keywords. We have discussed about the module, n module, begin, initial, right? Begin, initial, and what else we have discussed? N, and then n module, right? Begin, initial, and n module. So these are the keywords. Okay, these are the keywords that we mention when we are writing a particular code. So here, as we are discussing about 2 to 4 decoder, obviously this is our code, right? So this is about the 2 to 4 decoder. In this 2 to 4 decoder, how can we write a particular code of this 2 to 4 decoder? Is we should start with the module. As I said, module is a basic keyword where you have to start your keyword by resembling the particular keyword that you are using. It's a module. And decoder DF, this is nothing but the name of the circuit, right? Name of the module, name of the circuit. And then followed with the port list. So this is nothing but the port list. So port list consists of what? Input port, output port, and as well as in-out port, right? Always remember that this is a very basic first step in coding. When you're writing a coding of particular module that you are considering, remember that you have to mention with the keyword module and then name of a module, and then goes with the port list. And that port list should contain the input ports, output ports, and as well as the in-out ports. So here, as we are discussing about the 2 to 4 decoder, right? So we are discussing about the 2 to 4 decoder. Remember that in the port list, I have mentioned what are my inputs, what are my outputs, and as well as the in-out ports, right? Then, in the second statement, I'm clearly mentioning about the inputs. So my inputs are A, B, and E, right? So this is a 2 to 4 decoder. So this is 2 to 4 decoder, where I have A, B as input and E as the enable pin and D as the output, right? So output is how many bits? 4, 3:0 and D. So D is the output, 3:0 out of 4, right? It is 2 to 4. 2 input, 4 outputs, right? So my output would be 3:0. So totally how many bits I have to generate? 4. So 3:4 and D is the nothing but the output. So soon after declaring what are your inputs and what are your outputs, and also in the very first statements with respect to the keyword that you are mentioning and with respect to the port list, then you have to go, or else you have to move forward by assigning. Okay, assigning. What is this assigning? Assigning is another keyword with respect to the modeling styles. Keyword which is mentioned with respect to the different modeling styles. So as we are discussing about the data flow modeling, so I have to give, or else I have to assign some keyword, and that keyword is nothing but the assign. Assign. What am I assigning? I am assigning D3, D2, D1 and D4 with respect to the inputs and the enable pin, right? So A, B and E. So here, out of this, after assigning all my outputs with respect to the inputs, assign D3 as A, B and E, and then I can say that it is 0, 1, 2, 3. So here, after assigning, I'm ending my or else I'm terminating my code with mentioning the encoder. Okay, we all know how the mechanism, what is the mechanism of 224 decoder. So based on the enable bits, the D1, D0, D1, D2, D3. So these are my A and bit 0, 0, 0, 1, 1, 0 and 1, 1. So based on the enable bit, I can say that so when both my inputs are 0, 0, what happens? D1 will be, D0 will be enable and D1, D2, D3 will be disabled. So when my input, one of my input be as 1, then what happens? D1 is enable and all the rest of the bits will disable. 0, 0, 0, 0, 1, 0. And then when all my inputs are 1, then what can I do? 0, 0 and D3 will be enable. So this is nothing but the mechanism of decoder. But in terms of how we are writing the coding is very important to remember. So always remember, as we are writing a code in terms of data flow modeling, as soon as a keyword with respect to that particular modeling style should be mentioned clearly, and then the mechanism should be overwritten very clearly. And finally, you have to terminate your code with the module, one more module, that is one more keyword, that is end module. If you are starting with the module, then your keyword, then your code should end up with the end module. If you are starting anything with the initial or else begin, then it should end up with the end, right? So these are the few things to be remembered when you are writing a particular code in terms of data flow modeling, and also in terms of other behavioral styles as well. Then in the data flow modeling, as I said you, the conditional operator in Verilog HDL, it takes 3 operands, right? So in the conditional operation, see, in the different types of operators, we have discussed different types of operators: logical operators, bitwise operators, and conditional operators, replicable operators, and so on, right? So here, where I said you, in the conditional operators, in this conditional operators, how many operands can consider is A, B and C. Okay, so the conditional operators are represented with respect to the question mark. A, question mark and B, right? And question mark and B comma C. So this is how we can represent the conditional operators. And then see here, there it goes. Condition, true expression, false expression. Okay, condition true and false. Right. Then this operator is equivalent to an if-else condition. Okay, so this is equivalent almost to the if-else condition. So when it comes to the condition, what do we say? Condition statements. We have discussed different types of conditions, right? If condition, if-else, followed with the for. Okay, all these conditions we have discussed so far in this data flow modeling. So wherever in your program, if you come across anything, anywhere with respect to the conditional operators, remember that the conditional operators will go with either true or false followed with the question mark. Okay, then so this operator is almost equivalent to if-else condition, and the HDL given below shows the descriptions of 2-by-line, 2-by-1 multiplexer used in the conditional operators. So here, as we are discussing now regarding with these conditional operators, we can show as an example in 2-by-1 multiplexer. By using 2-by-1 multiplexer as an example, we can easily represent, or else we can easily demonstrate about the conditional operators in clear. Right? So this is a program with respect to 2-by-1 multiplexer where we are showing the conditional operator. So module, multiplexer 2-by-1, and in the port list we are representing our inputs, outputs and in outputs. So we know that in the the multiplexer will have, see, we are considering 2 by 1 multiplexer, right? So A and B are two inputs, and here is a selection output, and here the output as D, output we are representing with out. This is 2 by 1 mux, and this is a selection line, right? So based on the selection lines, we can able to know where the output is enabled or disabled, right? So here I'm starting my code, or else I'm starting the program with the module is a keyword. So I'm starting it with the keyword called module, and then the name of a module, that is multiplexer 2 by 1 multiplexer, and then I'm the port list. So in the port list, I'm just representing what are my input ports and what are my output ports. And then after that, the second statement is about clearly mentioning, or it's clearly I'm just representing the initializing the inputs and as well as the output. So the second line goes with this, the input initialization of the inputs A, B and select S, and the output as out, right? Then soon after that, what I should do is, as I'm discussing, or else as I'm writing my code in terms of data flow modeling, then I have to assign a keyword. So pertaining to the data flow modeling, I am assigning a keyword, assign keyword out. So output is all depends upon the selection lines with respect to the input, right? So output is equals to select question mark A is to B. Okay, so I can say that the best example that you can give based on the conditional operator is 2 by 1 multiplexer, right? So in the exam point of view, anywhere if you are asked to write a program, or else if you are asked to write a code in terms of conditional operator, using conditional operator, better go with the example as 2 by 1 multiplexer or 16 by 1 multiplexer as you wish. Then I'm assigning the output is equals to select A is to B, and then finally I'm ending up with a terminal called end module. Okay, so this is nothing but the data flow example under data flow modeling. And then we see the data flow modeling. This is a 2-bit counter, so 2-bit binary counter. So one more example, see, first example we have discussed about the decoder, right? So 2 by 1 first example is 3 to 8 decoder, and the second example is multiplexer 2 by 1 multiplexer, and third example is counters. Third example is we are discussing about the counters. So we all know counters. What are the counters are? Counters are meant to count the bits. So we can either count from up to down or from down to up, and we have other counters named called ring counter, right? So we have the ring counter, up down counter, up counter, down counter, and ring counters. So these counters are nothing but they just counts the bits. Okay, for each and every clock pulses, they just counts the bits. For example, decade counter we have. So in the decade counter, we have the decade counter, we have the up counter, we have the down counter, and also we have the up counter, down counter, and as well decade counter. For example, if you're considering this decade counter, decade is nothing but 10. So at each and every clock pulses, the counter it counts, right? So at clock 0, it counts 1. At clock 1, it counts 2. At clock 2, it counts 3. Like that, till clock, what do we say? Till clock 9, it counts 10. 10 clock pulses, right? So this is a decade counter. It counts only 10 bits. For example, if you are considering the up counter, what is an up counter? Up counter means it counts from up from that means from bottom to top. That is from 0, 1, 2, 3, 4, like that. This is nothing but the up counter. Down counter from up to down. So this is nothing but the down counter, right? So now this particular example, it's talk about the 2-bit binary counter. So it is about the 2-bit binary counter. If you observe the block diagram here, we have a circuit diagram where we have a flip-flop, we have 2 flip-flops. So 2 SR flip-flops. We have 2 SR flip-flops, and we have 2 gates. So what sort of gates are? So those are AND gates. 2 AND gates, 2 SR flip-flops, and then see, and also we have built a 2 binary up counter using master slave flip-flop. So we are discussing about the up counter. So we are just discussing about the up counter. So this is a 2 binary bit. So this is a 2-bit up counter. So those 2-bit up counter, how we are designing is by taking help of 2 flip-flops. This is one flip-flop and here this is another flip-flops. And these two are nothing but the gates, AND gates. And then if you observe the truth table for this 2 flip-flops, or else the truth table for this 2-bit binary up counter goes like this. So A and B, and we know that the 4 combinations are 0, 0, 0, 1, 1, 0 and 1, 1. And out of this 0, 0, 0, 1, 1, 0 and 1, 1, it has to come up counter. That means plus 1, right? 0 is a basic first, n as 0 and n1 as 0 plus 1. So how much it is? 1. And n2, it is 1 plus 1, it is 2. So on to, so with respect to 1 bit, increment of 1 bit, so we can easily increment it, or else we can up count it by with respect to the adding of 1 bit. So that's what here we are representing this Tn as a basic bit and Tn plus 1 is a incremental bit. So here it is, if you see 0, 0, okay, it is 0, right? It is 0. Then what is the output when you are incrementing 0 plus 1? So 0 plus 1, my output it has incremented to 1. And then it is 0, 1, 1. That means what? In the binary bit we all know 0, 0, 0. It is 0, right? And then to the 0, I am incrementing with respect to 1. So 0, 0, 1. It is 1. And onto this, I am incrementing one more 1. 0, 1, 0. It is 2. And onto this, I am incrementing 1. Again 0, 1, 1. It is 3. 3. And then onto this, I am incrementing 1. 1, 0, 0. It is 4, right? So 4 plus 1, it is 1, 0, 1, 5 and 1, 1, 0, 6 and 1, 1, 1, 7, right? So this is nothing but it up comes from down to bottom, from bottom to up, it comes 1 with the help of the increment Tn plus 1. Okay, so if you observe the right side, we have a, what do we say? This is a code. So in this code, we will discuss how the code has been written. So build a synchronous 2-bit binary up counter. So this is this coding is about 2-bit binary up counter, synchronous 2-bit binary. Synchronously, we are going to one bit is going to add up synchronously. So build a synchronous 2-bit binary up counter using master slave flip flop. So here this is a master slave flip flop. So we have 2 flip flops, SR2 flip flops, and onto the 2 flip flop, each flip flop are associated with a clock signal. See, this is a clock signal, okay, and then these 2 flip-flops are associated with 2 inputs at S and R, and the 2 outputs with the complement of output Q and Q bar, and those output are given as an input, one of the input to the 2 AND gates. So this is one AND gate and the 2 AND gate, and output of the AND gates are again given as input to the other flip-flop 2, okay, and the output are taken over as QA, okay. Q, the first flip-flop output is considered as QB and the second flip-flop output is considered as QA, right? And now if you observe the master slave flip-flop, the output of the input of first one is given as the output of the second flip-flop, and the input of second flip-flop is given as output of the first flip-flop. See here, so this is how we are giving, right? Okay, then now in the coding part we will observe module 2-bit counter. See, in the port list we have inputs and outputs, clock and clear, clock and clear, and inputs are Q and QB. Inputs again I am assigning as inputs clock and clear and output as Q and QB. And for this purpose, what am I doing is wire. As we have discussed in the previous slides, what is a wire? Wire is nothing but a physical connections where the 2 elements are to be, in order to get connected 2 elements, we are connecting it with respect to, with the help of wire. Okay, wire is sort of a net. Net is nothing but it's a variable. So wire SA and RA, that means with the help of wire I am connecting R and S, and wire QA, Q0, QB, and with the help of wire connecting, I'm connecting QA, Q0 and QB, QA, Q0 and QB. So I'm just connecting it with the help of wire. Okay, and then Assign. So I'm writing my coding with respect to the assign data flow modeling, the data flow modeling style. So I have to mention the assign keyword. Assign is Q naught and QB. Q naught A and QB. And then assign for RA, that is QA and QB. So this is QA and QB, and this is Q naught A and QB. Okay, so after assigning, so assigning is nothing but we are describing the gate structure. So this is a gate structure. See here, this is a gate structure, and to this gate structure we are describing. Okay, how we are describing? By using the assignment statement, we are describing the structure of this particular module. So this is how I am describing. How am I describing is SA. SA is meant for AND gate 1, and so this AND gate, the output is given as Q naught and QB. Okay, and then assign RA. So the one more AND gate, how am I describing this structure is with respect to QA. QA is one more AND gate, and that I am representing or is describing with respect to Q naught and QA and QB. Okay, so after assigning, what am I doing is the flip-flops. So the flip-flops R and S flip-flop, right? So this flip-flop with respect to B and the flip-flop with respect to A. Okay, so now I am mentioning what sort of port list that I can consider with respect to B and with respect to A. So with respect to B, I can go with this QB, QB naught and QB, clock and clear. And with respect to A, I can go like we have the QA naught, SARA and clock and clear. And finally, as I've started my code with the module, so I'm ending with the end module. Okay, so this is how I can write a program in terms of with respect to different structures, different block diagrams, or different electronic devices, right? So this is all about the binary counter. And so this is overall examples that we have discussed in data flow modeling. So far we have discussed about the decoders, multiplexers and counters, and how to write the code. If you are considering the data flow modeling, then remember that your code should consist a keyword called assign. Right? In all the examples that you are considering, whatever the examples that you are considering, remember that your code should contain a keyword called assign. Why? Because the data flow modeling style should write, or it has to, it is containing some keyword that is assign. Likewise, behavioral modeling contains a keyword called always at the rate. Right? So this is how we can write the code in terms of data flow modeling. I hope you all understand. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.